Good morning, everyone. Today we're going to start Unit 9, which is on circles. So day 1 notes are about arcs, angles, arc length, and sectors. So first we need to go through a whole bunch of definitions. So I have a chart here with the vocabulary word, the definition, a picture, the symbol, and the relationship. So a circle is the set of all points that are a fixed distance from the center. So here we have a picture of a circle. There is a symbol. This is something you need to know. That is the symbol for the word circle, and you name a circle according to its center point. So you would read this circle O, and you need to know that there are 360 degrees in a circle. You know, going around a circle, 360 total degrees. All right, a radius is a segment that connects the center to any point on the circle. Radii are things you need to look for because there's a relationship between them. They are line segments. So line segment OA and line segment OB are both radii. And it turns out they are congruent to each other. So this is something you need to know and you need to look for. All radii in a circle are congruent. Very important. Because if I gave you that this one was 3 inches, you need to know that any other radii drawn in that circle are also going to be 3 inches. All right, a diameter is a segment that contains the center of a circle and both endpoints are on the circle. So it goes through the middle of the circle, right through the center. You need to look for diameters. So this is a diameter, it's a line segment, AB. And you already knew that there's 360 degrees in a circle, so a diameter, since it cuts the circle in half, it measures 180 degrees. So there is 180 degrees on this side of the circle, there's 180 degrees on this side, and the diameter acts as a straight angle, so that means in here, there's also 180 degrees, and the same on the other side, 180 degrees. So you need to realize anytime you have a diameter, you get actually 4 180 degree measurements. Okay, an arc is part of a circle. You're going to need 2 or 3 points to name an arc. And just like angles, arcs can be named forward or backwards. So arcs are things you need to look for. Like for example, and here's the symbol, it's curved. You would read this arc TS. So find the letter T. Go to the letter S. So if you look at this, arc TS, here's your diameter, there's 180 degrees. That's called a semicircle, arc TS. Its measurement is 180 degrees. Now you could also go the other way, arc TS, arc ST, doesn't matter which way, there's both 180 degrees either way. Arc RS starts at point R, goes to S, or starts at S, goes to R. It's less than 180 degrees. It's smaller than a semicircle. That's called a minor arc. And you always go the shortest distance between 2 points of an arc. Arc STR. Now you got to start at S, go towards T, and then end at R. So STR is that one in green. It's more than a semicircle. Its measurement's going to be more than 180 degrees, and that is called a major arc. Okay? All right, let's flip. All right, just like we had segment addition postulate, angle addition postulate, there's arc addition postulate. So the measure of adjacent arcs can be added to determine the measure of a larger arc. Adjacent means next to. So we have the measure of arc CA plus the measure of arc AB. We don't have any numerical value, but we know it's going to equal the measure of arc CB. So you can add arcs, you can also subtract arcs. So if this was, I don't know, let's say 100 degrees, and this one was 30 degrees, arc CB would measure 130 degrees. Okay, next very, 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 very important topic in this unit is central angles. It's an angle whose vertex is on the center of the circle. So here is a central angle, angle AOB, and I drew the raise of that angle longer because I want you to see where it intersects the circle. It's very important that you can take an angle and zoom it out to the circle and find the arc that it intercepts. It's also important you can take an arc and follow the line segments backwards to find the angle it came from. There is a very special relationship between a central angle and the measure of its arc. They equal each other. They are congruent. If the angle's 80 degrees, the arc is 80 degrees. Angles and arcs are both measured in degrees. So very important, you need to look for central angles because again, you are going to get a measurement. Excuse me. Also very important are inscribed angles. It's an angle whose vertex is on the circle. It is completely inside the circle. Inscribed, inside, central, center. There's kind of a relationship between these words. So an inscribed angle, angle ACB is an inscribed angle. If you zoom it out, it intercepts arc AB. If you had arc AB and you follow those line segments back, it goes back to this angle. There's a relationship between the measure of an inscribed angle and its arc. The measure of an inscribed angle is half its arc. So if this angle was 40 degrees, the arc is 80 degrees. So there's shortcuts to this. You could say for a central angle, the angle equals the arc. For an inscribed angle, the angle is the arc divided by 2, it's half, or 2 times the angle is going to equal your arc. Very important. All right, here's a couple of examples. If the measure of arc AB is 70 degrees, so I'm going to go and put that in my picture, then the measure of angle AOB is, so you need to notice that is a central angle, and you need to know the relationship that it equals its arc. So that's also 70 degrees. All right, problem 2. If the measure of arc AC is 80 degrees, then the measure of angle ABC, in this case, it's an inscribed angle, it's going to be half. So the angle measurement would be 40 degrees. Problem 2B, we're going to use the same picture. I'm going to just redraw it real quick because I just drew all over and labeled the one, and now I'm going to have some different values. So the measure of angle ABC is now 36 degrees. We have to find the measure of arc AC. Inscribed angle, it's going to zoom out. It's going to be twice the measure of the angle. So that gives us 72 degrees. Okay? Easy. All right, next thing. Circumference. Circumference is defined to be the length around a circle. The length of a circle. Notice the word length. It's going to be measured in centimeters, inches, feet, miles, things like that. There are 2 circumference formulas. They're both on the reference sheet. C stands for circumference. It's either pi times d or 2 pi r. So that's on your reference sheet. Now arc length is defined to be the length along the edge of a circle from one point to another. So in this picture, if we wanted to find the length of arc AB, now notice I'm stressing the word length, which is different than measure of arc AB. We just talked about the measurement of arcs. Those are in degrees. Length is going to be centimeters, inches, feet, miles, etc., etc. Meters, kilometers. So if we want the length of this arc, it's part of the circumference. Circumference, length. It's part of it. We don't want all of it. So here's my circumference formula, but we don't want all of it. We want a fractional part of the circumference. We want a ratio of the circumference, a fractional part. So it turns out to be the measure of this arc, which again, remember, is in degrees, and you know all the way around a circle is 360 degrees. So it's this fractional amount of your circumference. So this formula is not, the whole formula is not on the reference sheet. This part is, but it's your job to remember you're going to be multiplying your circumference by this fraction. And again, key word right there is length. Well, it's really length of an arc, but length. So let's try some examples. Find the length of each arc. Leave your answer in terms of pi. Okay, it wants the length of arc XY. So we need to find this length. We are given the diameter. For this formula, you could either use diameter or radius. Radius is half. But we need the measure of this angle in degrees. We aren't given that. Here's the trick. You need to look at the picture. You need to notice things. I'm noticing this box. That means there's a 90-degree angle there. I am also noticing this is a central angle. And I know the rule, a central angle, the measure of that angle is equal to the measure of the arc. So now I'm ready for my formula. So we want the length of arc XY. That is going to equal the length of the arc in degrees divided by 360 degrees times 2 times pi times r. Now the degrees here cancels with the degrees there. And the only units left is going to be what my radius is in, which is inches. And it said leave this in terms of pi, so I am not going to be typing in the value of pi. So I'm typing in 90 divided by 360 times 2 times 8. And then I need to remember to put my pi symbol in there. Leave your answer in terms of pi. And the unit of measurement was inches. So there's your length. All right, let's try this one. We want now the length of arc XPY. That's a major arc. Find X, go towards P, go towards Y. So it wants us to find this length. Here's the measure of it, and 15 centimeters is your radius. So we're ready to go. This length is going to be 240 degrees divided by the 360 degrees times 2 times pi times your radius. All right, the degrees are going to cancel out. My answer is going to be in centimeters. So now I'm typing in 240 divided by 360 times 2 times 15. And that gives us 20. Leave your answer in terms of pi. So 20 pi, and this is centimeters. These are one-dimensional. So you just have inches, centimeters to the first power. All right, we have another problem. All right, this one was on a Regents exam one year. In the diagram below, circle 1 has a radius of 4, while circle 2 has a radius of 6.5. Angle A intercepts an arc of length, pi. Right there's my key word. I know this is an arc length problem. And angle B intercepts an arc of length 13 pi over 8. Dominic thinks angles A and B have the same degree measure. State whether Dominic is correct or not, and then explain why. I'm going to start with circle 1. Here, I'm going to use my symbol, circle 1. Okay, so arc length. They gave us the length of the arc. All right, so we're going to start with pi equals. Then we need the measure of the arc in degrees. We don't know that. That is my variable x. It's going to be the measure of this arc in degrees. We have to divide that by 360. Again, these degrees are going to cancel out. Then it's going to be 2 times pi times the radius. Pretty much we have to solve for x. All right, now, first part of the problem is a fraction. I'm going to put this over 1, make that a fraction. And I'm going to do 2 times 4 is 8. And then all this is in the numerator. So I'm just kind of rearranging. 2 times 4 is 8. I still have pi. I still have x. That's all on the top of the fraction. And then I have it equals 360. If you want, put that side over 1. Now you have a proportion. You can cross multiply. So I'm going to have 360 times pi equals 8 times pi times x times 1. Now, do you notice pi is on both sides of the equal sign? I can divide pi out. It's going to cancel out. So now I'm down to 360 equals 8x. Divide both sides by 8. 360 divided by 8 gives you 45. Now, 45 is the degrees of the arc.